I want you to write this logarithm in terms of x, y, and z. So log p is equal to x, log q is equal to y, and log r is equal to z. So you have to basically rewrite this logarithmic expression in terms of x, y, and z. Give it a try. So remember, the trick is with these types of problems is that you want to expand the logarithm fully. Fully expand the logarithm, so then that way you can replace log p, log q, and log r with x, y, and z. So we can start. How can we start this problem?
You rewrite it as log p squared minus log q squared r 6 to the 6.
Good stuff. So you applied the exponent to every piece on the inside of parentheses, and then you got rid of division by putting in subtraction. Very good. From here, where could I go? Okay. Just want to make sure that you keep that in parentheses because technically you are subtracting this entire second logarithm in that first red line. And so then the next line would be what? Yes, because then you want to make sure that you distribute that negative over, get rid of that parenthesis, and then I can do what from here? I can make all my exponents be coefficients. And now that I have just log r, just log q, and just log p, I can replace each one of those with x, y, and z. So your final answer should have been 2x minus 2y minus 6z. Did we get that?
Yes.
Good stuff. All right. Let's try this one. We're going to rewrite it in terms of x, y, and z. So somewhat similar to the last one. We have exponents, we have a division, we even got a square root in this one. Square root is the same thing as saying what?
To the power of 1/2.
To the power of 1/2. So really and truly, we could kind of rewrite this as just to the 1/2 power. And then we can start expanding this by doing what? Good stuff. Okay, so you have multiplication between r squared and q to the 1/2. You have the division of p to the third. So then you can expand it this way. And now we can take care of all the exponents because we have no more multiplications or divisions. And this becomes
2 log r plus 1/2 log q minus 3 log p.
And from here, we can go ahead and replace log r, log q, and log p with x, y, and z. So 2x plus 1/2 y minus 3z. Sorry, I had my variables in the wrong places. R was before p. So 2z plus 1/2 y minus 3x. Now, your different laws of logarithms and your change of base formula can be used to rewrite different logarithmic expressions in terms of other variables. So in this case, it says if log base a of 2 equals x and log base a of 6 equals y, then we have to find in terms of xy log base 2 of 6. Now, first off, since we're trying to rewrite this in terms of x and y have a base of a, and this particular log has a base of 2, they are not the same base. Now, that doesn't mean that it can't be done. That just means that we're going to need to change our base. Okay? Which you can do. You can change bases of logarithmic expressions. You use the change of base formula, which you guys wrote down earlier, yes?
Yes.
Okay. So the change of base formula, which is log base what?
Log base a equals log.
Wait, it was a log base a of b?
No, log base b of a.
That's okay, yeah. because I want to make sure I have it the exact same way as it is on your formula. So then you'll have a log base C of A over log base C of B. That C can stand for any base that you want it to be, okay? And since I'm trying to rewrite this in terms of X and Y, the base that I want them to be is going to be a base of what? If I'm trying to write this logarithm, which is log base 2 of 6, in terms of X and Y, and X and Y both have these respective bases, I want to change this base to what? I want to change it to A, because the only way I'm going to put in an X is if I have a base of A. Only way I'm going to put in Y is if I have a base of A, so I need to change this to be a log with a base of A. So when I match up this logarithm to the formula, the 2 is the B, and the 6 is the A. So then that means it's going to go into the change of base formula like so. Log with the base of A, because that's what I wanted to change it to, of 6, because this is the same, over log base A of 2. That's how you use change of base formula. And you can change it to any base you want. This is very helpful when it comes to solving. It's helpful when you're trying to maybe even use your calculator log button and you need to change this log to a base of 10. You can change any base you want to. And now that I have this, isn't this what I wanted to rewrite in terms of X and Y? What's log base A of 6?
Y over X.
And log base A of 2 is X. And that is my answer. That's how I write that log of log base 2 of 6 in terms of X and Y. Okay? Same directions, we have a new log. Okay? So same stipulations, a new log. I have log base 6 of 2. I'm trying to rewrite this in terms of X and Y. And I don't have the same base. So I probably want to change my base. I'm going to change my base to what? A. And this time it's going to be log base A of 2 over log base A of 6. And again, we have exactly what we needed. So this is going to equal what? X over Y. So log base 6 of 2 is equal to X over Y. Now, yes, these are pretty simple, pretty straightforward. Okay, but I want to make sure everybody understands how you can use change of base to rewrite this in terms of other variables. Okay? Same directions. This up here is going to stay the same for all these examples that we do. Okay? This is going to stay the same for all the examples we do. Okay? Let's look at this one. We have log base 2 of 36. Log base 2 of 36. I want to write this in terms of X and Y. Well, first off, do I have the same base? No. So I already know I'm going to need to change my base. So it's going to be log base A of 36 over log base A of 2. That's using the change of base formula. Now, unfortunately, unlike the other two, I can't just plug in X and Y and say that I'm done. I'm not done yet. Granted, my denominator is now what?
X.
Is now X. But my numerator, it is not log base A of 6, nor is it log base A of 2. But isn't there a way that I can maybe change or alter that 36 to be what? 6 squared. So I have a log base A of 6 squared. I talked about it in the other examples before we got to these. I cannot plug in X if that exponent's there. It has to be fully expanded before I can even substitute in any variables. So what do I need to do to that too?
Put it to the log.
Put it beside the log. So it becomes 2 log base A of 6 all over X. And now I can plug in the Y. What's my final answer?
2y over X.
2y over X. So log base 2 of 36 is 2y over X. So when I look at this one, I have a log base A of 24. I have the exact same base of what I'm trying to rewrite it in terms of, so I don't have to use change of base here, okay? I only use change of base if I need to change the base. So now it's just a matter of trying to rewrite 24 so that way I have log base A's of 2's and log base A's of 6's. How can I rewrite 24 so that it's only in terms of like 2 and 6? 2 times 2 times 6. Okay? Since all those are being multiplied together, you can technically expand them using what? Product law, which says that I am going to do what to every single one of these? Add them. So it's going to be log base A of 2 plus log base A of 2 plus log base A of 6. And now I have exactly what I wanted. That becomes x plus y, which is the same thing as just saying 2x plus y. Here, yes, you do want to keep going because you can combine like terms. Okay? Let's try another one. Okay, do I need to change my base here? Yes, I do. So I have a log base A of 12 over log base A of 6. And as we can see, my denominator gets replaced with a y. But 12, is there a way I can rewrite 12 so that it's in 2's and 6's?
Log base A2 plus log base A6.
Very good, because technically if I'm adding, I will multiply my arguments, and 2 times 6 is 12. Perfect. So now this becomes x plus y over y, and that is my final answer. I cannot cancel those y's. I cannot cancel those y's because that y in the numerator is being added to that x. It's like they're married, okay? And you just can't cancel that y out, okay? With that y at the bottom. Their marriage is strong, okay? That addition is strong, okay? Now, if they were being multiplied, then yes, they're single at that point. You can cancel out that real quick, okay? Let's do one more. Do one more. For this one, do I have to change my base? Yes, so this becomes log base A of over log base A of 2. Good stuff, okay? And we can already see our denominator is x. Now, it will not always happen that the denominator will be actually one of our things, okay? We just happens to be in these cases. How can I potentially get 3, though, from 6 and 2?
Log base A6 minus log base A2.
Very good, because 6 divided by 2 gives me 3. So then, of course, I can always expand a division by using subtraction. 6 minus 2 with the respective log base A's. So then this just becomes over x. Can I cancel out the x's? No. Because they're married. Even though there's a difference there, their differences still keep them together. Okay?
Yeah,
their differences
it's
still
not a
keep them
happy
together.
relationship.
Yes, it's a struggle relationship, but they're still together. This is the last one. This is also something that IB likes to do. They give you a log, and then they want you to rewrite it in a different form. Okay?
Vlog.
Oh, I was like, what? Log base 3 of 1 over 27x squared. They want you to write in the form of a plus b log base 3 of x.
The people at IB use Tumblr.
So that basically means that I can expand that log so then that way it can be written in that form. So division means what?
They're being subtracted.
So then I can do log base 3 of 1 minus log base 3 of 27x squared. Okay? Can I expand this anymore? How so?
The 27x.
That 27x squared can be what?
It's log base technically squared.
Log base 3 of 27.
Plus log base 3x squared.
Very good. What should I do with that minus?
Distribute.
So I have a log base 3 of 1 minus log base 3 of 27 minus log base 3 of x squared. But what?
You combine the log base. You move the exponent on the x into the front of the log.
I can move that exponent to the front of the log. Oops, which we don't need in the back. And now that's actually this part right here. It is in that form. These other 2 logs can actually be evaluated to give you the A that you need. Log base 3 of 1 is what? It is 0. Think about it. If I wrote an exponential form, 3 to what power is going to give me 1? 0. What about log base 3 of 27? It is 3. 3 to what power gives you 27? And that is 3. So this expression, this log base 3 of 1 over 27x squared, when written in the form of a plus b log base 3 of x, is negative 3 minus 2 log base 3 of x. Questions? That is how you use your properties and your laws of logarithms to expand, to rewrite, to evaluate, and you'll see next time we meet how to also use those laws and properties to solve exponential equations.